Morning, grade 7. Today we're going to talk about mutually exclusive events. If you look in your textbook at a lesson 11.5, it does have a very detailed definition of what a mutually exclusive event is. But what I've tried to do is simplify it for us so that it's not so mathematical, but it's in basic English. So if two events are mutually exclusive, it means they can't happen at the same time. Okay, that's the definition I want you to focus on. They're mutually exclusive if they can't happen at the same time. So, for example, typically when I get dressed, I would not wear pants and a skirt at the same time. Okay? Those events of wearing pants and wearing a skirt are mutually exclusive. It cannot happen at the same time. Okay? Whereas me wearing pants and a white shirt is not mutually exclusive. I could do that at the same time if I wanted to. So let's take a look at a few more examples. So keep that in mind throughout this whole lesson. Mutually exclusive can't happen at the same time. Here are some examples. So here's an example of something that is mutually exclusive. Turning left and turning right. You can't do that at the same time. You do one or the other. So they are mutually exclusive of each other. What about tossing a coin? Heads and tails are mutually exclusive. It can't land on heads the same time it lands on tails. Yeah, it could land on heads and then the next time land on tails, but it can't happen at the exact same time where it lands on heads and tails. Same with if I were going to pull a card out of a deck of cards. I pull one card out of a deck of 52 cards. Kings and aces are mutually exclusive. If I pull out one card and it's a king, it can't also be an ace at the same time. Okay, so there are events that happen at different times. They can't happen together. But then let's look at the opposite, things that are not mutually exclusive. Okay, like let's say you're driving in a car or even going on a walk, turning left and scratching your head. That's not mutually exclusive because you could do that at the same time if you wanted to. While you're turning left, you could scratch your head. Okay? Same with if you pull another card of the deck, kings and hearts. It's not mutually exclusive because it could happen at the same time. You could pull out a card that's a king of hearts. Okay? So, mutually exclusive is, by definition, here we go, events that can't happen at the same time. That's the most important thing for this lesson. Okay, so here we have an example of the cards, okay? Aces and kings, mutually exclusive. They are separate. Either you get an ace or you get a king. But I could pull out a king of hearts. This is not mutually exclusive because it could happen at the same time. So let's take a look at that a little bit more in depth. So let's do a little bit of review on probability. So remember, the probability of an event happening is the number of ways it can happen over the total number of outcomes. This is, again, what we talked about before. This is the theoretical, okay, in theory. Let's see if it fits. Theoretical probability. So, for example, in a deck of cards, there are 4 kings out of 52. So my probability is really 4 out of 52, okay, which I could simplify to 1 out of 13. That's the probability of me just pulling a king out of a deck of cards. So in theory, if I reach into a deck of cards 13 times, in theory, one of those times I'm going to pull out a king. That's basic probability that we talked about yesterday. But now let's talk about that in terms of a mutually exclusive event. Okay? What about when two events are mutually exclusive? It's impossible for them to happen together. So let's think about that as an example with cards. What are the chances of you pulling out a king and a queen? So again, picture a deck of cards. You reach in, you pick a card. Maybe you're doing one of Callum's magic tricks. What's the chance that when you pull out that one card that it's a king and a queen? And is the most important word here. The chances are impossible. If you are pulling out one card, it's impossible because they are mutually exclusive. It can't happen at the same time that you have a king and a queen. You would either get one or the other or a different card. Okay? So when we see this word and, and then my probability is 0, it means that my events are mutually exclusive. They can't happen at the same time. There's no chance of me pulling out a regular card that's a king and a queen at the same time. But now let's talk about or, okay? So for mutually exclusive events, here's a definition up here, the probability of A or B is the sum of the individual probabilities. Well, let's break that down. So we're not saying let's pull out a king and a queen. Can't do that at the same time. Let's say, what's the chance of pulling out a king or a queen? So in order to figure that out, what we can do is we can go down here. We can go, well, the probability of a king is 1 out of 13. But then the probability of a queen is also 1 out of 13. So we can combine these two events. The probability of a king or a queen is 2 out of 13. Okay, so back to our definition up here. Okay, when events are mutually exclusive, okay, we can figure out the or by adding up the individuals. Okay, so let's try that with something a little bit simpler. Okay, take a look at this spinner. Okay, we have red, blue, orange, and purple. They're all divided equally. Yesterday we practiced, well, what's the probability of me spinning red? Theoretically, in theoretical probability. Well, the chance of me spinning red is 1 out of 4, right? I think you would all agree with that. Then, what's the chance of me spinning blue? Well, it's also 1 out of 4. But now let's ask ourselves, are spinning red and blue mutually exclusive events? Can it happen at the same time? It can't. Either I spin red or blue or orange or purple. I can't spin red and blue at the same time. Therefore, they are mutually exclusive. So what I can do is I can figure out the probability of spinning a red or a blue by adding together the probability of spinning red and the probability of spinning blue. And I get 2/4, which is 1/2. Okay, so we're saying with mutually exclusive events, events that cannot happen at the same time, and I want to find the or between two of those events, I can just add up the individual ones, okay, of red and blue. But then remember, this and is different. What's the chance of me spinning red and blue at the same time? Well, it can't happen, so my probability is 0. So let's try that again with different colors. Let's make my eraser bigger. Come on, here we go. Okay, so let's say, what's the probability of me doing purple? What's the probability of red? And what's the probability of orange? So I should be able to lay, okay, probability of purple is 1 out of 4, red is 1 out of 4, and orange is 1 out of 4. So because I know these events are all mutually exclusive, they can't happen at the same time, that means if I do, what's the probability of me spinning a purple or a red or an orange? Well, or means what I can do is I can just add up the individual probabilities for each of these colors to get the overall probability. So I have 1/4 plus 1/4 plus 1/4 equals 3/4. So the probability of me spinning a purple or a red or an orange is 3/4 because they are mutually exclusive events. Let's take a look at another spinner. Let's take a look at this one. So let's pretend I want to find the probability of spinning orange. I notice that my spinner is divided into 6 sections. 3 of them are orange. So if I just wanted to know the probability of spinning orange, I would say it's 3/6, which I can simplify to 1/2. In your lessons, by the way, always simplify when you can. Then I could do, if I wanted, I could say, what's the probability of me spinning A? Well, I notice that there's only 2 A's on my spinner. So the probability of me spinning A is actually 1/3. But now we need to ask ourselves the question, Are orange and A, spinning those, are they mutually exclusive events? Are they events that cannot happen at the same time? Well, let's look carefully. If I look at orange, I should notice that I could spin this spinner and I could land on something that is orange and has the letter A. So therefore, these are not mutually exclusive. So then my formula of adding these together for OR does not work. Okay? They're not mutually exclusive because I could land on orange and land on A at the same time. They could happen at the same time. So then my formula from this page of adding them up together doesn't work. It won't give me the actual probability of landing on these. Let's try another spinner. Let's say I have this spinner. So I have colors and I have numbers going on. So first let's figure out the probability of red. So I see my spinner is divided into 8 sections. So I have 8 outcomes and 2 of them are red, which I can simplify to 1/4. So the probability of landing on red is 1/4. What about the probability of me landing on an odd number? Well, there's still 8 options that I could land on and 4 of those are odd. So I have 1 out of 2 chance of landing on an odd number. Now let's take a look at red or odd. Would we say that these are mutually exclusive events? So we need to think, mutually exclusive means it can't happen at the same time. If I look at my spinner, is it true that red and odd are mutually exclusive? That they can't happen at the same time? Well, look, red has, I guess it doesn't work to highlight on there. Let me undo that. Here we go. Red has an odd number and an even number. So therefore, the probability of red or odd, it's not mutually exclusive because I could spin and I could end up on a segment of my spinner that is red and odd. So these are not mutually exclusive. It doesn't mean I can't figure out the probability for it. It just means that I can't add up the individual probabilities to figure it out. Okay? What I could do instead is I could go, well, what's the chance of me landing on red or odd? Let me look at my options. Here's option 1, that's odd. Option 2, that's odd. Option 3, it's red. Option 4 is odd. And option 5 is odd. So what I actually have is the probability of red or odd is 5 out of 8. I just can't get that from adding up what I have over here, my 2 individual ones, because the events are not mutually exclusive. I know that's a little bit confusing. So what I'm saying is, actually, let's just erase this orange one to give us a bit more room for a second. What I'm saying is the probability of red or odd, I can figure that out by looking at my spinner. But what I can't do is I can't do the probability of red plus the probability of odd because these guys are not mutually exclusive. Because then what I would get is I would get 2/8 plus 4/8 and I would get 6/8, which is different from what's actually on my wheel. So because these are not mutually exclusive, I can't just add up the individual probabilities. But let's see if I can do that with orange. So let's say if I want to do, what's the probability of orange, sorry, it's a little messy, or even happening? What's the probability of orange or even? So first let's check, are they mutually exclusive? Which means it cannot happen at the same time. If I look at my oranges are odd. That means orange and even are mutually exclusive. So what I can actually do is I can do probability of orange plus the probability of even will give me the probability for this event right over here. So probability of orange is 2 out of 8, and the probability of even is 4 out of 8. So I get 6 out of 8, which I can do is 3/4. So in summary, if events are mutually exclusive, I can add the individual probabilities to get my final one. If they're not mutually exclusive, I cannot do this step. I need to look at a sample space or look at what's in front of me. Okay? So, to emphasize, when you're trying to figure something out, the probability, first check, are your two events mutually exclusive? Which means it cannot happen at the same time. If it can't happen at the same time, then what you can do, like let's say you have a spinner, the probability of green or landing on, let's say, a 4. Let's say they are mutually exclusive. That means I can add the probability of green with the probability of 4, and I will get the probability for this event up here. Okay, it's quite confusing. I tried to do some complicated examples so that the textbook's a little bit easier, but feel free to ask me some questions.